So we're talking about conditional and all of that jazz, probabilities. The slot machine has 3 wheels. So on the wheels you have 9 symbols, 4 bars, 2 lemons, 2 cherries, and 1 bell. What's the probability all 3 wheels display a bell? I have one way to get a bell, so I have one way out of 9 on my first wheel. This is wheel 1, right? Then I got wheel 2. Wheel 3. How many ways can I get a bell on the first one? 1 out of 9. Second one, 1 out of 9. Third one, 1 out of what, 9? And I'm timesing. And then I get 1 over 729, which is this. So if that's like the big money, you have less than a percent to win. What's the probability that exactly 2 wheels display a lemon? So I got 2 wheels display a lemon, so I got 2 out of 9. So this is a lemon, this is a lemon. So I have 2 out of 9 ways, 2 out of 9 ways. Well, the probability that the third wheel isn't a lemon, well, I have to get 7 out of 9 because then I got 4 bars, 2 cherries, and 1 bar, which would work out. So then 2 times 2 times 7, which is 28. 9 times 9 times 9, 729. Here's the thing. That can happen 3 ways. I can go lemon, lemon, not a lemon. Lemon, not a lemon, lemon. Or I can go not a lemon, lemon, lemon. So that's where I'm timesing by 3. So then 28 times 3 is 84 divided by that. 0.11. So I got a 10% chance of getting at least 2 lemons, which could be big money. So here's the thing, that my slot machine has changed and I have stars added on. So, right, is the probability to get a bell higher or lower or about the same on the new slot machine? Make sure you explain your reasoning. I'm going to say it's lower. This is why. The new slot machine has a lower probability of 3 bells since there is still only one way to get the bells, but there are more total possibility outcomes. So if I add 4 more, so that's going to make it out of 13. So I get 1 out of 13. And if I times that 3 times, that is less than what I had before because 13 times 13 times 13 is definitely smaller than 9 times 9 times 9. So assume that we have this. P of B is 0.25. So this is B, this is A. The intersection of A and B is 0.15. I got a little diagram for that. And the probability it's not A or B is 0.6. That's on the outside. If this is 0.15, I need to get to 0.25. That's 0.10. So those add up to give me 0.25. Here's the next piece. Wants me to find the probability of what? A. You guys, check this out. These have to add up to 100. So 0.6 add 0.25 give me 0.85. So right here that's 0.15. So here's the thing. Probability A is 0.15. Not quite, because what am I missing right here? The center part plus 0.15, which gives me 0.3 what? 0. Okay, so you guys, we have this one is continued. If we randomly pick a person, what's the probability that person is divorced or separated? So how many people are divorced or separated? 3,949 out of my total, which give me that percent. What's the probability of being a female? Well, this is the probability of being a female out of my total, which is 49%. Then my next question, if someone is widowed, what is the probability they are male? So I've widowed 140 male, so it's going to be 36 out of 140, which is 0.257. What is the probability a randomly chosen person is now married and male? So now married and male is the 9,740 over my total, which gives me 0.137. And then we're moving on to our next problem. 2 fair dice are rolled. We get a sum of exactly 4 or 5 2 times. So here's the way to think of it. 2. Well, how many ways can I roll a 2? A 3, a 4, or a 5? There's only one way to roll a 2, 2 ways to roll a 3, 3 ways to roll a 4, 4 ways to roll a 5. Just thinking about that right there. So give an example of an outcome that favors the event. 2 and 2 gives 2 a 4, 6 and 5 11, but 4 and 1 is a 5. So I have a 4 or a 5. Exactly 2 times. So then it doesn't work. 5 plus 1 is a 6, 4 plus 3 is a 7, 1 plus 1 is a 2. Doesn't favor the event. What is the probability of getting a sum of 4 or 5 on a single pair of dice when I roll? Well, my little diagram I did up above, 3 plus 4 is 7, so it's going to be 7 out of 36. What's the probability of getting this event? So I can get a 4 or 5 exactly 2 times is 7 over 36 times 7 over 36, and then the flip side of that of not getting a 4 or 5 is going to be 29 over 36. So here's the thing. I have 3 ways to get this. 4 or 5 times a 4 or 5, not a 4 or 5, right? Same thing, so that's where the 3 comes in. When you multiply this out, this is what you get, which goes down to 0.0913, which is almost 9%. I don't know, I might bet on that, depending on my mood. I think it's pretty high. Okay, rain and fog, guys, Venn diagrams. Okay. So rain is 45, so those two have to add up to 45. Fog is 45, those two have to add up to 45, and the probability of rain and fog is 0.2. So 0.2 goes in the center, 0.025, 0.025, and then on the outside it all has to add to 1. If I add those up, that's 70. On the outside I get 0.3. So overlap means you'll have both rain and fog. What's the probability of rain and or fog today? I have to add them all up. 1, 2, 3, which is 70%, and then neither is what? 0.3. Last but not least, 2 fair dice rolls. What is the probability that the total is less than 5? So remember, 2 you get 1, 3 you get 2, 4 you get a 3. So you add those up, 6 out of 36 because it's less than 5, not equal to 5. So then you got 6 out of 36 is 1, 6. So then what's the probability that the new total is less than 5? And a 3 shows on at least one of the dice. So here's the thing. Ways I can roll a 2 are 1 and 1. Ways I can roll a 3 are 2, 1 or 1, 2. And the ways I can roll a 4 are 2, 2, 3, 1 or 1, 1, 3. So there's 2 ways I can get a 3 in this combination. And it's out of 36 because that's how many. So it's 1 over 18.